let's just jump right in. On this first slide, I have a position versus time graph made, and our ultimate goal is we want to make a velocity versus time graph based off of the position versus time graph. So the first thing we need to do is we need to figure out the velocities in these various sections of our position versus time graph. And I have these different sections because you can see that we have three different motions represented within this position versus time graph. Now remember that the slope of a position versus time graph tells us what the velocity of that object is. So to begin, I'm going to say slope 1, which is going to be our slope in section 1 here. That is going to equal velocity 1. And remember that the slope is just rise over run. But we have to be a little bit careful when we calculate our slope, just because we want to make sure that we're getting the direction right, because we are finding velocities. So to find the velocity in the first section, I'm going to be taking, for my rise, I'm going to be taking 3 minus 13. Okay, we always take our final position minus our initial position. So I'm going to be taking 3 minus 13, and then our run is just going to be 5 minus 0. 5 minus 0. And that's going to give me negative 10, and I'm going to put my units here now, and this is going to give me 5. Because remember, our rise units are meters, and our run units are seconds. So if we calculate that out, we are going to get a velocity in section 1 of 2 meters per second. Now slope 2, which is going to be our velocity in section 2, well, we have a horizontal line in section 2 here. And we know that that indicates that we're not moving, so our velocity there is just 0 meters per second. Finally, slope 3, which is going to be velocity 3. Our rise, again, we want to take final minus initial, so our final position is 11, and we're going to subtract 3, so we have 11 minus 3. And then our run is going to be 16 minus 8. So 16 minus 8. So this is going to give us 8 meters over 8 seconds to give us a velocity in section 3 of 1 meter per second. So now we have all our velocity information, so we can start creating our position or our velocity versus time graph. I apologize. So I'm going to mark 1. And then I'm also going to mark negative 2, because those are the relevant velocities that we calculated. So in section 1, from 0 to 5 seconds, we were going at a constant negative 2 meters per second. So again, we have a straight line here that's showing us that we are at a negative 2 meter per second velocity for this 5-second period. Now in section 2 we had no motion, so we can just draw a horizontal line right here on our x-axis. Okay, and then finally in section 3, from 8 to 16 seconds, we were at a constant velocity of 1 meter per second. So there is our completed velocity versus time graph. Now, we also discussed this past week that a velocity versus time graph can give us some very critical information in terms of the displacement of our object. We said that the area under our velocity versus time graph gives us the displacement of the object. Now, we know that these two shapes here, 1 and 2, are rectangles, so we can very easily find the area of these two shapes. So we know that the area of a rectangle is base times height, so our base for area 1 is 5 seconds, and our height is negative 2 meters per second, And if we calculate that out, we're going to get negative 10 meters. That's going to be our area for area 1. Now for area 2, our base is 8 seconds. So we have 8 seconds. And our height is just 1 meter per second. So if we calculate that out, we get 8 meters. And now we can just add these two areas up to get our displacement. So that displacement is going to be negative 2 meters. Now we can check to see if this answer is actually correct by taking a look at our position versus time graph. Now remember, to find displacement, we always take our position final minus our position initial. So our position initial in this position versus time graph is right here at 13 meters. Our position final is way over here at 11 meters. So this is our position final. So now we can just plug these two values in. So our position final is 11 meters. Our position initial was 13 meters. If we do that math, we see that our change or our displacement, our change in position, is negative 2 meters. Okay, so this slide again goes through the process of how to create a velocity versus time graph from a position versus time graph, but also remember that the area under a velocity versus time graph can give us the displacement of that object. All right, next, this slide, we have a velocity versus time graph already made for us, and our goal is to create an acceleration versus time graph. So similar to a position versus time graph, the slope of a velocity versus time graph tells us something, and that something is the acceleration of the object. Okay, so for this velocity versus time graph, we have to find our slope in section 1, which is going to give us the acceleration in section 1, and we have to find the slope in section 2, which is going to give us our acceleration in section 2. So again, slope is rise over run. So our rise here, again, this is negative, and we always need to take final minus initial. So I'm actually going to do just part of section 1. I'm going to go from here to here. So our final in this time frame here, our final velocity is 0. So I'm going to write in 0. And our initial was 10. So we're going to have 0 minus 10 here. And our run there is just 5 minus 0. So 5 minus 0. And that's going to give us negative 10 meters per second over 5 seconds. Again, I wrote in those units. Remember that our rise units on a velocity versus time graph are meters per second, and our run units are seconds. So if we do this math, we get a acceleration of 2 meters per second squared. Now for slope 2, our rise, we're going to be taking 0 minus a minus 6, okay, because our final velocity here is 0, and our initial was negative 6. So we're going to take 0 minus a minus 6, and our run here is 10 minus 8. So we have 10 minus 8. So if we do this math, we're going to get 6 meters per second divided by 2 seconds, and that's going to give us an acceleration in section 2 of 3 meters per second squared. So now we have our acceleration numbers, so we can actually start creating our acceleration versus time graph. So I'm going to mark 3 up here, and I am going to mark negative 2 down here because those are our relevant acceleration numbers. So now we just create it. So in section 1, we had a constant acceleration of negative 2 meters per second for this entire 8-second period, okay? You see that the slope of our line never changes here. So we know that we were going negative 2 meters per second squared for this whole 8-second period. So we can just draw, see how straight I can draw this? We're just going to draw a straight line from 0 to 8 seconds. And now from 8 to 10 seconds in section 2, we're going at a constant 3 meters per second squared. Okay, so there is our completed acceleration versus time graph. Now, we can also gather some useful information from an acceleration versus time graph. We said that the area underneath an acceleration time graph is going to give us our change in velocity. Now again, area 1 and area 2 here are rectangles, so we can very easily find those areas. So area 1, our base in area 1 is 8 seconds. So we'll write in 8 seconds. And our height is negative 2 meters per second squared. If we do that math, oh, I forgot the negative here, negative 2 meters per second squared. If we do that math, we're going to get 16 meters per second, and that's negative 16 meters per second. All right, now in area 2, our base is 2 seconds, and our height is 3 meters per second squared. And again, if we do that math, we are going to get a value of 6 meters per second. Now we can add these up, and we can get a change in velocity of negative 10 meters per second. And there we go. Now we can check this change in velocity again by using our velocity versus time graph. So our initial velocity in our velocity versus time graph is right here. This is v initial, and that's 10 meters per second. Our final velocity is right here where we ended, and that is 0 meters per second. So that is our v final. Now to get our change in velocity, again, if we were finding a change in something, we're always taking final minus initial. So to find our change in velocity, we're taking v final minus v initial. So our v final is 0 meters per second, and our v initial is 10 meters per second. So therefore, our change in velocity is negative 10 meters per second. So you can see that our area under the curve value from our acceleration versus time graph matches up with our change in velocity value from our velocity versus time graph. So I hope this video sheds some more light on motion graphs. Again, I really believe that through struggling this week through motion graphs and just grappling with that content, I really think that this stuff is going to make more sense now because of this video lecture. So with all that being said, I hope you have a great weekend, physics students. Take care.